So one of the big deals about inverse functions is that they reverse each other. So if I take a function f of x and we talk about its inverse function, first of all, okay, we have a name for it. It looks like this, f superscript minus 1 of x, and that's read as f inverse of x, okay? Or the inverse of the f function, evaluated at x, okay? So we've seen a couple of weird notations. We've seen f of g, g of f, etc. But now we've seen f inverse of x. But I'm still going to use this notation. Note, if an inverse function reverses, they reverse each other. So for example, f of x is, I'll use x cubed again, and then its inverse function is the cube root of x. These guys undo each other. We have the following situation, and it's an important one. So I'll put it in blue, and I'll say f of f inverse of x is equal to x, and also f inverse of f of x is equal to x. Now that's a little unclear, but I wanted to put it up here, and you can see it happening right here. So for example, if this function f of x takes the number, I don't know, 2 and works on it, it'll be 2 cubed is 8. However, if I do f inverse of 8, I get the cube root of 8 to go back to 2. So there's a lot of things to notice here as we work our way through this section. You know, inverse functions, they do the reverse. This guy takes a 2, gives you 8. This guy takes that 8 and brings back to 2. So that's why when you compose them one after another, they yield up identity, okay? Think of the function machine as you imagine that, okay? So a function machine for these guys, any of them would be, well, okay, I'm going to put, like, say, f inverse of x here, and back to back, I'll put another function machine here, and I'll call it f of x. And what happens is, if these guys are inverses, no matter what number you took and placed in this guy, you'd get f inverse of x. But then if you plug that into the function, it reverses it and brings you back to x again. Okay, so think of the cube function 2 to 8, and then the cube root function 8 back to 2. Okay, but now here's the thing. For us to have an inverse function, our function has to be what they call 1-to-1. Okay, what is 1-to-1? Let's read. So each x value pair with only one y value, and each y value pairs with only one x value. Why is this a big deal? Well, when you reverse a function and find its inverse, we want it to be a function too. And it's not like you can't have an inverse, but it just won't be a function, okay? So if f of x contains the pairs 2, 3, and 2, -5, then it's not a function because x is paired with two y values. If f of x contains the pairs 2, 3, and 5, 3, it's still a function. But it's not 1-to-1 because if we reverse this function, we no longer have a function since going backwards, the value 3 is paired with two different values. So I'm kind of dropping a few hints as to inverse functions, and not so subtly either. But this stuff we'll finally see on the third video where we put it all together and talk about inverse functions. But we've already been doing a bit of a chat as it is. So what the heck is a 1-to-1 function? Well, I have this silliness of, well, this is a drawing I got from the internet, and basically the function f will take x and plan it and map it to f of x. The inverse function will take that and reverse it for you. But if you reverse any function, it may not be a function itself, and this leads us to the horizontal line test down here, and perhaps you've heard of it. We all know about the vertical line test, remember? Vertical line test. What it says is if I've got a function wandering through space, as long as I don't hit it more than once with a vertical line, it's a function. Okay? But we've seen functions that are not, we've seen relationships that are not functions. You know, you could talk about, oh, I don't know, a circle. A circle you can hit twice. This is not a function. But basically it boils down to this. If your original function, right, is not one-to-one, that is to say, if it fails what we call the horizontal line test, where you can hit it twice, that means there's a y value. Let's say, think of 2. 2 has 2 x values. Oh, that's fine. This is a function, but this is not a one-to-one function. Why? Because a horizontal line intersects it twice. So what? It's still a function, right? But here's the thing. If I go for its inverse function, this is what happens when you invert a function. They turn sideways, and we'll talk about that a little bit briefly in the next video. But what happens is if I take the inverse and I switch the ordered pairs, now all of a sudden I'm hitting it twice. And so now this implies that its inverse function is, its inverse is not a function, is what I should say. Its inverse is not a function. And so what if that's the case? We don't care, but we do. Okay, we want it to be a one-to-one function. So what kind of function is one-to-one? This is an easy thing to show you. A one-to-one, that's my abbreviation, a one-to-one function, okay, is either always increasing, now watch out, there are exceptions, but this is what we typically see, or always decreasing. So consider in the next video, you're going to see a graph of the cube function, but let's take a look at it right now. The cube function, remember, is that piece of spaghetti floating through space like that. Look at how, it passes both tests. Of course it passes it's a function test because I can only hit it with one vertical line. I can only hit it once with a vertical line, I should say. And look at how it passes the horizontal line test. No matter where I strike it, I can only hit it once. So it's always increasing. We're interested in the following function. It's called an exponential, and an exponential function typically does this. Up, or it could be descending like this. And we don't know this yet, but that's what exponentials look like. And the exponential functions are one-to-one. What does that mean? Okay, that implies they have an inverse function. Okay, and that's it for this particular video. What they do, though, I will say in the homework, they'll say stuff like, is this guy one-to-one? And they'll give you a problem like y equals x squared minus 1. And the question is this one-to-one? And what you do is you go, oh, let me see. I know how to graph that thing. It's up 1. It's a parabola. Now I'm going to run the vertical line test. Let's see. I'm sorry, the horizontal line test. Boom, I hit it twice. No, not one-to-one. So this has been a scattered kind of presentation on what one-to-oneness is and why it's necessary. It just means that if I take the inverse, the inverse is going to be a function also. How do I test it? Horizontal line test is the way to go. So that's also part of the homework. And I like to break it up into these concepts. So that's it for this one. I'll see you at the third and final for this section. Third and final video.